Good day, everyone. Our topic for today is linear Diophantine equation. Now, linear Diophantine equation is an algebraic equation for which rational or integral solutions are sought. An algebraic equation is one that involves only polynomial expression. The Diophantine equation is the polynomial equation which the coefficients are integers, and Diophantine equation whose solution we seek in the set of integers or natural numbers. The most basic Diophantine equation is the linear case. We can write ax plus by equals c, where a, b, c are all integer numbers. Now, let's talk about the theorem 1 of linear Diophantine equation. Ax plus by equals c has a solution if and only if d equals a and b divides c. So if d divides c, it has many solutions. Let's find out. If we have the equation, now if we have 33x plus 14y equals 115 equation, then we have ax plus by equals c. So we have a equals 33, which is from here, and b equals 14, which is from here, okay, and c equals 115. And from the theorem 1, ax plus by equals c has a solution if and only if d equals a and b divides c. Our given is we only have a, b, and c. So let's find the value of d. Alright. How do we find the value of d? So let's recall the topic of Euclidean algorithm. From the theorem, we have d equals a and b. So we have a here, the value of a is 33. And the value of b is, we have 14. So we have here 33 and 14. Alright. Using the Euclidean algorithm to find the GCD of these two numbers. The GCD of these two numbers, 33 and 14, using the Euclidean algorithm. 33 divides 14 equals 2, so times 2 here, plus 14 times 2 minus 33. So we get 5 plus 5 here. Because 14 times 2 equals 28, and 33 minus 28 equals 5. 5, so we add 5 here. And copy paste the 14 equals the remainder 5, right, times 14 divides 5 equals 2. 5 times 2 minus 14, so the answer will 4. So plus 4, then 5 equals the remainder 4. 5 divides 4 is 1 plus 1. So 4, yes, just continue the process. So 1 times 4, so we don't have the remainder na, so plus 0. So here is our GCD. So therefore, our D here equals 1. So the value of D is equal to 1. Now, according to the theorem, it has many solutions if D divides C. Alright, so D divides C, so the value of D, we have 1 here. So 1 over C, the value of C is 115. So 1 divides 115 is 115. So 150 divides 1. Yes, it has many solutions. So that completes our theorem 1. Now, let's proceed to theorem 2. The theorem 2 states that the equation ax plus by equals c has no integral solutions if d doesn't divide c. Now, if we have the equation 6x plus 51y equals 22, and we have ax plus by equals c, so we have a equals 6, b equals 51, and c equals 22. And let's find the value of d. So let's prove the theorem 2, that if d equals a and b, if d does not divide c, then it has no solution. So d, we first find the GCD of the value of a and b. So let's find the value of a, which is 6, and the value of b, which is 51. So 6 and 51. Use the highest number. So the highest number here is 51. So 51 equals 6. So that it is easier for us to get the GCD. So 51 divided 6 is 8. So 6 times 8 is 48. And 51 minus 48 is 3. So we have to add 3. We have to add 3 here. And 6, copy the 6. And then the remainder is 3. So 6 divides 3, it's 2. So plus 0, we don't have remainder now. So 3. Therefore, D is 3. The GCD of 6 and 51 is equal to 3. Alright. According to the theorem that if D, the value of D, which is 3, has no integral solution if it does not divide C. So the value of C here is 22. So C is equal to 22, and 3 doesn't divide 22. Therefore, it has no solution. Therefore, it has no solution because 22 divides 3 has no solution because it does not divide. Now, moreover, if D divides C, then there are infinitely many integral solutions. So, if ang D divides C, it has infinitely many integral solutions. Moreover, if x is equal to x sub o and y equals to yo is a particular solution of the equation. This 2 is the particular solution of the equation if D divides C. Then all solutions are given by x equals xo plus b over d times n, and y equals yo minus a over dn, where n is an integer. We already know that there is a solution if and only if D divides B by the theorem 1. So for the second part of the theorem, let xo and yo be a particular solution. So we have here axo plus byo equals to c. If we put the value of x here equals xo plus b and over d, and y equals yo minus a and d, where n is any integer, then we have ax plus by equals a, alright, a times x, so the value of x here, so we replace the value of x which is here, so a the quantity of x o plus b n over d plus the b, so the value of y here is here, so it is the value of y, so we replace b, the quantity of y o minus a n over d equals ax plus by equals c. So x, y are also solution. So if d divides c, and then we use xo and yo as a particular solution, so the value of x and y also are the solution. Alright. We know from the previous theorem x and y integers, since d divides b and a, this gives us many solutions for the different integers n. Let us show that these are any solution x and y be any integer solution. So ax plus by equals c, a, the quantity of x minus xo plus b, y minus yo equals to 0. So by dividing by d, if we both this equation we both divide by d, so we get a over d times x minus xo equals negative b over d times y minus y0. So we get we will get a divides d times bn over d, y minus yo minus a n and d. So let's illustrate the theorem. Example 1. Find the solution of 155x plus 45y equals 7. So we have here 155x plus 45y equals 7. So we have ax plus by equals c. So we have here the value of a equals 155, right? Then the value of b we have 45, and the value of c we have 7. So let's find the value of d. So d equals a and b. So this is our formula. So d equals the value of a we have here. So we use the value of a and the value of b. So the value of a we have 155 and the value of b we have 45. So let's get the GCD. So 155 equals 45. digicity using the Euclidean algorithm. So 155 divides 45 equals 3. And 45 times 3 is 135. So 155 minus. So 155 equals 45 times 3 plus 20. 45 equals 20. So 45 divides 20, it's 2 plus 20 times 2, 40. 45 minus 40, it's 5. So 20 equals 5, the remainder. Yes, we have the remainder here. So 20 divide 5, it's 4 plus 20 minus 20, it's 0. So we don't have the remainder here, so the digicity is 5. So 155 and 45 is the digicity. The greatest common divisor is 5. So the value of D here, it's 5. Therefore, D divides C equals 5 divides 7. Oh, it has 5 divides 7, no solution. It has no solution because 5 doesn't divide 7. Now let's proceed to the next example. Find all solution to 60x plus 33y equals 9. So we have here 60x plus 33y. The given equation is 60x plus 33y equals c. So we have here a equals 60 and b equals 33, and yes, letter c equals 9. So let's find the value of d. It's the value of d. So d equals a and b. So value of a, we have here 60 and 33. So 60 and 33. Let's find their GCD. 60 equals 33. So 60 divides 33 is 1. So it's 1 plus 60 minus 33, it's 27. Alright. Then 33 equals 27. Remember, then 33 divides 27, it's 1 plus the difference between 33 and 27, it's 6. So that is the remainder. To continue the process, 27 divides 6, that's 6. Alright. 6, so 4. 27 divides 6, it's 4. Plus 6 times 4, it's 24. 27 minus 24, it's 3. And 6 equals 3. 6 divides 3, yes, it's 2. Plus 6 times 6, 3 times 2 equals 6, and 6 minus 6 rather, it's 0. So we will get 3 here as the GCD. So 60 and 33, GCD is 3. Alright. So therefore, the value of D here is 3. Now, to get the value of x and y, let's reverse the step. The substitute for checking to find the value of x and y. So since we already find the value of d, so let's check first if it has many solutions. So if d divides c, so 3 divides c, which is here, it's 9. Yeah, it's 9 here. So 3 divides 9. Yeah, definitely So we can search. Yes, it has many solutions. So we can search for a solution. Let's reverse the step in here. Right? 3. So 3 equals 27. Alright? Reverse the step so we can find the value of x and y. So 27, we write 27 here. If we reverse the step, so we will minus, right, diba? We will minus the product of these two numbers, which is 4 times 6. 27 minus 4 times 6 equals, if you try to solve this equation, 27 minus 4 times 6, the answer will 3. Alright? So, 27. Now, let's proceed to the next, which is 6. So, the value of 6 is 33 here, and 1 times 27. Alright? Since 6 here equals 6 here, 6. 33 minus 1 times 27. So, diba? 6. So, muna 6. So, what will happen? It turns like that. So, 6. So, let's put the value of 6 here. So, let's copy 27. 27 minus 4. Then, here. The value of 6, which is 33 minus 1 times 27. So, it will times 33 minus 27. Right? Next, we have 27. 1 times 27 minus 4 times 33. So, distribute. Alright, distribute the value. So, 4 times 33 plus times 27. Alright, so we will combine these two since they have the same. Combine equals. So we will get 5 times 27. 1 plus 4. 5 times 27. Copy the 4 times 23. 33, I mean. So 4 times 33. Next, we have 27 here. The last, alright. The last here is 27 here. So we have 27 also here. So let's get the value of 27 equals 60. So 60 minus 1 times 33. So let's distribute here. It's 27, so it's gonna be here 27. Alright, so 5, copy, 5 times 60 minus 33 minus 4 times 33. Alright, then equals 5 times 60 minus 5 times 33 minus 4 times 33. So let's combine these two. So we have 3 equals 5 times 60 minus 9 times 33. So now, from the reverse steps of Euclidean algorithm, we will get the value of u and v. Right? Let's represent this one, this value as u and v. So u equals 5 and v equals negative 9. To find the value to find the value of x and y. Let's represent the reverse steps of Euclidean algorithm 5 and negative 9 as u and v. As you can see here, our given equation, our given equation here is 60x plus 33y equals 9. As you can see, from the reverse steps, we have here 60x plus 33y equals, right? 60x, we have here 60 and then 33. Therefore, we will use 60 as u equals 5 and then v equals negative 9. Therefore, b, which is b over d and yo equals v times. So, to find the value of xo, alright, so from the example, we get the value of u. It's u equals 5, v equals negative 9. Now, to substitute to get the value of x, 0 equals 5, which is u, times 9 over 3, which is the value of b, the value of d equals 15. So 5 times 3 equals 15. And then the y, which is negative 9, right? From the equation of 60x plus 33y. So 33 is y, so therefore 60x, so the value of 60x, so therefore x here is 5. So x0, we will use this 5 as x, represent here as y and x. So negative 9 and 5. We have now the value of x is xo is 15 and yo is negative 27. Now to find the value of x and the value of y, we will now substitute these two numbers. So x equals the value of xo, which is 15, plus b, from the given equation, the value of b is 33, and over the d, the value of d is 3. Right? So equals x equals 15, 33 divides 3, it's 11, and so that is, we will now can find the value of x. Now for the value of y, equals yo minus an over d equals yo, we have negative 27 minus a, just from the equation, a is 60 and over 3. So y equals negative 27 minus 20. 60 divides 3, it's 20. And so this is now the equation. We will now can find the exact value of x and the exact value of y. So let n, if n, where n here, right? So don't forget that n here are all integers. Integers. Alright, and here are all integer numbers. So if n equals 1, so we have here x equals 15 plus 11 times 1, we have here 26 and y equals negative 27 minus 20 times 1. If y equals negative 27 minus 20 times 1, then y equals negative 47. Now, if n equals 2, x equals 15 plus 11 times 2, we have 37. And y equals negative 27 minus 20 times n as 2, we have negative 67. And so on. So if you will provide the value of n, so if you let n as any integers, you will definitely get the value of x and y. So that is all about how to get or how to find linear Diophantine equation. So I hope that you will learn from this video. Thank you and goodbye.